Hi, and welcome to this Active Metro blog series. Today we will be taking the first step into a brief history of Metro. There will be 3 parts in total for the history, and we're starting out with the need for Metro and the differences between replication and Metro. So the real question is, how do you survive data center destruction, right? So here you see an example of a data center being hit by a tornado. You can imagine there's no workloads coming out of this data center anymore. And the next question, of course, is how do I recover from such scenario? But in fact, it doesn't have to be that big to be a real issue. Imagine that an excavator digs through a power line or through a network connectivity line. This will disable your data center just the same, and you still need to recover from that, right? So any failure, big or small, may need some form of disaster recovery. Now, most people are familiar with the term DR, or disaster recovery. Far less people with DA. You want to take a guess? DA stands for disaster avoidance. So this is basically the difference between a disaster just happened or a disaster is about to happen. So in case of the tornado, the disaster happened, right? So something broke. I now have a problem. My workloads are down. I now need to recover. The other side of the coin is something like the water level in my data center is rising. There will be a short circuit soon and I'll lose access. So I'd better start moving my data or moving my applications proactively to another data center in order to avoid the disaster. So disaster recovery, something broke down, I need to recover. DR on one side, and DA, disaster avoidance, I'd better proactively move my stuff before things start to fail. So these are basically, DR and DA are basically replication and Metro. So the replication will allow you to do a DR. DA, more or less, you could restart your workloads elsewhere. You're right, you could do a failover, but you would still suffer from downtime. Where DA with a Metro solution could be capable of actually moving the data moving the apps from one data center to the other without any downtime. So that's a more granular or more sophisticated way of doing disaster avoidance. So in the history of time, it all started with replication. Yeah, so someone had this bright idea, said, okay, so I have data in 2 places. Why don't I replicate the data from one data center to the other and from the other data center back to the first one? So really cool, right? It allows you to have your data in more than one place, which means that you can recover from any disaster because your data is safely replicated to another data center. There's also downsides to it, because as you are doing replication, the target volumes are always in a read-only mode because they're being written from the other data center, right? So there is no way that an application could access one of those volumes because, well, they're read-only. So in order to do disaster recovery, you would have to take action and actually talk to the storage array, make sure that you break or reverse replication and promote them to read-write enabled before you can actually recover. So there's 2 different flavors in replication. The first one is asynchronous replication. Basically, you are capturing all of the writes in one data center, and every once in a while, you're committing those writes to the other side. And that means that you don't have any limit in distance between those data centers because it's asynchronous. But also, as disasters usually strike randomly, you probably lose some data when you have a DR, right? So you got to be prepared for that. It's got to be acceptable in your environment to actually lose some of the writes that you've already done to one of the data centers if disaster strikes. If you don't want that, the other option is synchronous replication. So in synchronous replication, any write that you perform to one of the data centers gets mirrored to the other side instantaneously before the write is actually acknowledged back to whoever was writing. Cool part here is that whatever you write, so every byte that you commit to one data center also gets committed to the other one. The downside is distance, because the write only gets acknowledged once you've completed the write to 2 data centers, which means you need to traverse the WAN, which means that any writes that you do will incur more latency as the distance between the data centers gets bigger. So usually what's accepted is around 5 milliseconds of latency. So 50, maybe 70 kilometers apart is probably the max that you want to put these data centers in for synchronous replication. So this is replication. Another form is metro. And metro is also a synchronous way of doing things. So it is limited to a certain distance, but metro is slightly different from replication. What if I have the data in one location and I mirror that data to another location? So if I mirror the data and I have the storage layer basically simulate that this is one big volume, I can make it appear to whoever's using that volume that the volume is actually read-write capable and available at the same time in both of the data centers. So this means I could move my workloads without any issue, because wherever the workload resides, Metro will always make it seem that the device that I'm talking to or the volume that I'm talking to is local. So this is a pretty cool way of doing things. There are different architectures, which I'll discuss in the next episode. For now, thank you for watching and stay tuned for the next one. Bye-bye.